In this video, we will discuss protocol layering and service models for the internet. So, the internet or networks in general are complex. They have many pieces. You have hosts, we have routers, you have links of various media, applications, protocols, hardware, software. So is there any hope that we can organize our discussion of network structure? Just organizing the structure of a network. Before we answer that question, let us look at this organization of air travel. Okay, so let's say you buy a ticket and then eventually you go to the airport, you check in your baggage, and then you eventually make your way to the gate, you get loaded onto the airplane, and then your airplane takes off from some runway, and then that airplane is routed from one air traffic control center to another, and eventually it's going to get to the destination airport, and then it will be assigned a runway where it would land, and you get to the gate, and you deplane, and then you go and claim your baggage off some carousel, and then eventually you call up your airline and you complain, I had XYZ problem on the flight. Maybe I only got a bag of peanuts or whatever. So you notice here that you really have a series of steps. Okay, so we can think of this airline functionality as a layered model. Okay, so you have one layer on the departing side where you purchase your ticket, and that would correspond to the process on the arrival side where you complain about some issue with your travel. Okay, you need a ticket to complain about that. You check in your baggage. On the receiving side, or when you land, you're going to have to claim your baggage. Okay, you get to the gate and you can load, get off the airplane as well through a gate, and so on. So you notice we have these layers, and each layer implements a service, right? The baggage layer would accept on the departing side. It accepts your baggage, okay, and then you eventually get checked in. On the arrival side, you can claim your baggage from the airline, and you notice that each layer will rely on the services that are provided by the layer below it. So the ticketing process will rely on the fact that you can check in your baggage, and the baggage check-in relies on the fact that you can actually board that airplane, and so on. So layering then is a way to allow us to deal with complex systems. And when we do layering, we basically develop an explicit structure that allows us to identify the relationships between the different pieces of some complex system. And typically you have a layered reference model which will facilitate the discussion. Now, this layering is basically a way of discussing modularization, a very common concept in computing. And modularization, as you may have learned in earlier courses, allows or eases the maintenance and updating of a system, because you can change the implementation of a layered service without affecting the rest of the system. So for example, say we changed our boarding procedure, right? And now we want to board an airplane in terms of persons who have the smallest carry-on luggage, for example, instead of the way it's done right now where you board from the back of an airplane. As long as that process accepts a list of passengers and boards them, and by the time it's done all the passengers are on the flight, we really don't care, right? The upper layers can still work as usual. The lower layers can still work as usual. Everything will still look transparent to the rest of the system. So can layering be considered harmful? Well, there is some discussion about that because sometimes layered systems do perform poorer than monolithic systems. But in general, layering is very useful. So the model that we're going to use in this course is this 5-layer um, Internet Protocol stack. You have the 5 layers are the application layer, the transport layer, the network layer, the link layer, and the physical layer. The application layer supports network applications. These are just the applications that we have all come to use and love. Things like FTP, the file transfer protocol, SMTP, the simple mail transfer protocol, HTTP, hypertext transfer protocol, SSH will be at that layer as well. Even SSL that we do use is actually an application layer protocol. The transport layer allows for process-to-process data transfer. Okay, and so protocols like TCP and UDP are transport layer protocols. We're going to study TCP and UDP in a few weeks. And then the network layer primarily supports routing of datagrams from a source to the destination. So protocols like IP, the Internet Protocol, and routing protocols like RIP and OSPF and BGP, which are routing protocols. These are all operating at the network layer. And then the link layer will support data transfer between neighboring network elements. So protocols like Ethernet or 802.11, as we see with Wi-Fi, or the point-to-point protocol, which was used for dial-up. These are all examples of link layer protocols. And then the physical layer simply would represent the bits on the wire. Now, if you pick up an old networking textbook, you will notice that you may probably find this ISO or OSI reference model, which has 7 layers. Now, you would quickly notice that those 2 layers, there are 2 layers here that are not present in our 5-layer model, and those 2 layers are the presentation and the session layers. The presentation layer just allows applications to interpret the meaning of data. So encryption or compression of data or any other machine-specific conventions, those should be implemented in the presentation layer. The session layer will allow for synchronization and checkpointing and recovery of data exchange. Now, why does the internet stack miss these? Well, the idea is that these services that are implemented in the presentation and the session layer, the idea for the internet is that if these services are needed, they should be implemented in the application layer itself. So if you recall when I first talked about the application layer, I mentioned that SSL, the secure sockets layer, this is basically what we use whenever we're doing secure online transactions where you see a lock in your browser. SSL is actually an application layer protocol. That's an example where we need encryption, and so that is actually implemented in the application layer. Now, the application and the transport layer are implemented only in end systems. Okay. The other layers, the network layer, is actually implemented on each and every device except for layer 2 devices. The link layer and physical layer are implemented in every device. Okay. So encapsulation then, the way it is basically the way layering manifests itself with data. And the key idea with encapsulation is that the data from layer n becomes the payload of layer n-1, right? Payload is simply what is being carried. So with encapsulation then, say we have an application layer. Without loss of generality, let's just assume that HTTP, but it could well be any application layer protocol. So our application will generate a message. That message then gets passed on to the transport layer, and the transport layer will append a transport layer header, H sub T, and now the application layer message is then put in the payload of our segment, and then this segment is passed on to the network layer. This segment then is going to become the payload of a datagram, and then the header of that datagram is a new network layer header that would basically specify the source IP address, the destination IP address, and a few other things. This then gets put, this datagram then becomes the payload of a link layer frame, and our link layer will put on a link layer header, H sub L, okay? And here you're going to have the source hardware address of this machine, and then the destination hardware address is actually going to be the hardware address of the default gateway of the router interface to which this computer is connected. So that would be this router here. And then that gets passed on to the physical layer, and it's going to go, in this case, through our switch. And you notice the switch is a device that operates at layer 2, in other words, a link layer, and it will have a physical and a link layer. Okay, so it gets to the router, and then when it gets to the router, the link layer header is stripped out, and then we go up to the network layer, and we consult a forwarding table, and that forwarding table will indicate how this datagram should be treated. And then it is now, that datagram is now put into a new link layer frame, and then it is sent on to the destination. Now when it gets to the destination, it is demultiplexed. Okay, so encapsulation, and the opposite is demultiplexing. So now it is stripped out. So the link layer frame, okay, is received eventually, and then you pass on the payload of that link layer frame to the network layer. The network layer does some checks and then passes on the transport layer segment to the transport layer. The transport layer then passes on the message to the application. Okay. By the way, I failed to state when I initially talked about layering that our layers are actually numbered from 1 to 5, okay, with layer 1 being the physical layer and layer 5 being the application layer. So when I say the payload of layer n becomes, the data from layer n becomes the payload of layer n-1, that simply means, for example, the data from the application layer becomes the payload of the transport layer, because the transport layer is layer 4. So this ends this recording. In the next recording, we're going to talk about networks under attack.